Hello and welcome to the Co-Location Green Talk at Sustainable Places 2020. You are at the steer track. Hi, my name is Karl Rabe. I'm the project lead and sales director for Co-Location.Green. We run sustainable IT infrastructure in a wind farm and are excited to share our insights and knowledge. Let's get started. What I'm going to talk about, you just heard, I'm an engineer by trade, lots of experience in the IT world, a couple of companies founded there to actually get sustainable IT off the ground. After that, I'm going to talk about how and why we measure CO2, especially in data center, how we enable sustainable HPC, and how do we recover heat. Personally, this is my third kickoff for sustainable IT infrastructure. We started off with a company called WindCloud and Brother in 2015. Had a nice energetic setup, storage battery, wind farm, biogas backups. But the grid configuration and the grid operator made it impossible for us to go through at that location. Due to the loss of location, we found another WindCloud company, which is WindCloud 4.0, which is now still active and present, running under the windcloud.org domain. They too want to offer sustainable IT infrastructure, just go down a different path. And today we focus on Co-Location.Green, which is directly hosted within the wind farm and just allows for massive scalability, the best energy prices in Germany, and a special approach to data center building. There were some learnings, there was some progress over the time. So we definitely increased our energy supply and the approach and how to get more and more sustainable energy into the data center over the time. And we, needlessly to say, we're massively improving our data center infrastructure. We started off WindCloud Brother with a old and rusty shipping container, which we modified with only the technologies we understood. It had cooling, it had fast internet, and that was about it. At WindCloud 4.0, we built a proper ISO certified and in the meantime EN 5600 certified data center infrastructure, and all those learnings we are now improving and building out at the Co-Location.Green facilities and locations. And we are creating modular data centers, so no shipping containers anymore, but low footprint approach to house and host massive amounts of sustainable infrastructure and HPC computing. What hasn't changed, the underlying idea is always get the massive amounts of wind capacity installed in North Germany and create sustainable and competitive IT solutions with it. Just as a very brief sum up of this picture, IT operations, data center operations, the internet in total is a massive source for energy consumption, greenhouse gases, and e-waste. All the buzzwords you've ever heard, all the buzzwords that are flying around, new and old, are creating trends that demand for more data center capacity, for more IT servers and equipment to be run in those data centers, and those all are growing at a rate that is actually being predicted that data center users will be the largest single IT or source of CO2 emissions by 2030. This is just a slightly different variation of all those problems together. We're looking at an exponential function, and we are much rather moving towards the red line within all those predictions on how the digital energy consumption is evolving. So we really need to act. How do we measure CO2? Since we are at the sustainable places, I'm sure that people are familiar with the three scopes. Here's a nice example I took from the Green Web Foundation, which I highly recommend you to check out, because they are even talking, I think, in the SDR track as well, and they have made a lot of efforts to look into and to go through to get your footprint in IT down. Scope 1 basically is everything a company burns directly in fossil fuel. Scope 2 is the energy, and Scope 3 is your supply chain, which is the most discussed at the moment, because that is still quite very difficult to figure out how to really reduce this. How does this look in a data center? Just briefly, first of all, we run our backup generators once a month for maintenance, which is accounting for CO2. Obviously, we looked heavily into how to solve Scope 2, how to use renewable energy directly for the IT equipment and without using fossil-based electricity. We moved our IT to the renewable sources. Scope 3 is everything we as a colocation provider are doing, basically anything else, from construction of the data center, from sourcing of materials, from our traveling to fairs and customers. All those is falling into Scope 3. What technically is a bit challenging is the service. Since we are a colocation provider, is that the CO2 amount that goes into the servers is not really associated for our operations. We have already looked into solutions, and you've heard probably here already solutions on how to fix this from Ali, from IT Renew, but this still remains one big issue in the CO2 and the overall CO2 emissions of IT application usage and IT operations. Just some numbers. So fairly easy and quick evaluation how our carbon emissions are distributed over the scopes. Scope 1 is fairly small. Scope 2, the energy, is a mixture of wind energy, which is accounted for 11 grams per kilowatt hour, plus the 5% we have to consume from the grid. So in combination, we face about 22 grams of carbon per kilowatt hour. And Scope 5 is basically the construction of the data center infrastructure, plus travel, plus everything we do over the course of the data center, over the lifespan, or an estimated lifespan of the data center of 15 years, divided through the total consumption of energy. So this depends obviously on a lot of factors that are not totally fixed, especially hard to predict in the beginning. But this is a fairly high value for what we're doing here. So compared to the German average of energy mix, which is the value I just looked up this morning, of the actual energy production in production in Germany as of today, we save a massive amount of carbon per kilowatt hour. But this does not make us carbon free yet or carbon neutral. It just presents a massive reduction that we also communicate towards our customer, that we also, with every bill, we will also have the savings accounted for as in our billing systems. So how do we actually solve this? The last bit. How do we come to carbon neutrality? Since we are running HPC systems, which we hear on the technology later about, we have the possibility of reducing the heat. This is the actual big beneficiary of HPC technology, because the CPUs and GPUs are not ideally cooled by air anymore, rather than water, which gives us a high level of temperature and massive amounts of kilowatts in heat. And by the 70% that we can actually use of the energy, we emit the fossil burning, for example, for using our heat to dry wood chips or to use them in a heat grid. We avoid fossil energy being burned, and if we add this into the mix, then our carbon emissions, which we are not free of, are compensated by a value that even makes us carbon neutral, and even above that, slightly carbon positive. So this is the math behind this. But how do we achieve actually this reuse of heat? Why are we moving into co-location? Why do we want to be a co-location provider? Gartner predicts that from today until within the next 5 years, 80% of traditional data centers will have closed down their data center. And this is a massive opportunity for us. Partially, these workloads will go to the cloud, partially, and mainly, we hope they will go to specialized co-location providers like us to be able to grow quickly and start off new locations and further megawatt deployments for our data centers. Why do we work so hard to create a cost-effective product in Germany? So basically, we are located here in north of Germany, and just 30 kilometers away from us, behind the Danish border, is the so-called 5 cent region, which stands for the Nordics, that have a massive growth in the data center industry, because all of those green highlighted countries offer sustainable energy below 5 cents per kilowatt hour, and this is where most of the HPC projects move. So we just go through great lengths to create data center services and products that are so attractive that we still are able to get some of those industries, hold them in Germany, and get them actually being deployed in Germany. This is our setting. This is another view from our data center locations. You see here on the right 8 foundations for data center modules. They are ready to deploy, and a switch yard for 300 megawatts. Each of the 80 plus turbines has over 3 megawatts of capacity, and so they all are combined create a total capacity of 300 megawatts within this switch yard. This picture is nice too in some other specific ways. One is I've actually grown up in this location back here. We see the North Sea here, and we already have heat use cases very close by. In this direction we have a pig farm, crop dryer and a biogas plant with their own heat grid. We will also build a heat grid in the other direction to the next village which also has an existing heat grid for our energy to be used. This is our electric setup, which is quite unique. So what allows us for the best, having the best electrical energy price for any data center in Germany, basically is due to a new mode of grid operation where the wind farm, the wind producers also become their own grid operator. This is the transformator in the middle you just saw on the picture ahead. But what is happening now, the wind farm also is operating its own grid on this 20 kilowatt level, so that the energy is transmitted via its own grid. And by running your own grid, there's some advantages, including that you are able to supply energy to any commercial company. So this is represented by us, by colocation.green product. And the benefit for actual data center operation is that our switchyard is connected to two redundant 100 kilovolt settings to the standard grid. So even if we wouldn't have any energy operated, we still have the chance to keep on running the grid over one of those backplanes. How does our setting look like? So you saw on the picture, you saw 8 foundations. We've already projected 5 of those, standard business IT and an OCP module. Those are air-cooled bays, which we just briefly touch with pictures. This is, your standard 5 kilowatt density, not that exciting, just very redundant, all the bells and whistles and certifications. This is our HPC module that is directly water-cooled, direct to chip, and the other HPCs are immersion cool module, where we are using tanks to run our workloads in. So this is the standard business modules, redundant data centers for maximum availability and security. This is the OCP module with lots of cooling because of a relatively high rack density, which still needs to be air-cooled. And now we jump into the HPC modules. This is our direct-to-chip HPC module, where you can see here nicely that there is still cooling modules installed, because we cannot reuse the heat at all the time. Additionally, there's still air coolers on top, which means not 100% of the heat created is moving into the water for cooling. There is still fairly high share that needs to be cooled via air. So this explains the setting. And the immersion module, which we have not fully designed, but will be looking like a similar module. I just wanted to show you how those tanks look like. Those tanks are connected at a very high temperature level with a fairly easy redundant pump and moving to a cooling solution. So you basically never need to create artificial cooling to cool those down, because they can run at a relatively high temperature level. This is the view inside one of our data center modules. You'll notice that there is not only compute modules in here, which are paired with 4 racks each, but also a storage part, a management rack, and a UPS to buffer the storage in case of an energy outage. On the right you see the central distribution unit, which distributes the water through the racks and out to the cooling. Very important that these redundant pumps, these are the pumps to make the energy usable for the community heat grid. The heat energy is transferred out to the heat grid and coming back as well here, and this way the energy can be used. Here you have our quick look at the water cooling setup. This was the CDU we just saw. This is the circle to the individual racks, coming back at a temperature level of 62 degrees, which will go over a heat exchanger out to the cooling units at 57 degrees. So depending on your temperature this is you can expect temperature around 60 degrees to be usable for any application. We already have, as I showed you, community heat grid, crop dryer, the pig farm, as well as the whole area around this switchyard will be becoming a commercial area, which will be the only commercial area in Germany who offers renewable energy at best price and renewable heat. This is a first in Germany, and I think that will be very attractive, and we won't see any issues in reselling our heat in a very close proximity. How's the actual cooling done within the racks? Here you see a typical water-cooled server, 4 CPUs each with copper cooling plates that are supplied with cold water, each individually on all 4 nodes, so they're not one after each other, so the temperature is not raised from the first CPU to the 4th, but they all get the same cool water flow in parallel, which helps to get the maximum performance out of each CPU. And the hot water is then moving out within a chassis like this, and here you see a manifold which connects to 6 of those servers, and they all then combine in the back of the rack and going out to the CDU. So this is the way how the energy is actually moved from the chip, from the RAM, from components in the front of the servers out to the piping to the central distribution unit and then the cooling. So let me just go briefly, just as a reminder for us, how we are, if I've missed something, or what are the features that we actually can do. Renewable power, massive scalability, all the certifications. Right. Okay. So to sum this up quickly, we run data center modules in a wind farm, creating circular energy systems, and have the massive potential to reuse heat in the data center, and by thus creating a sustainable eco data centers around our data centers, at the plus that our customers can expect the best sustainability for any data center in Germany, a high profitability due to very efficient operation modes, and effective and efficient operations for HPC, and the best data center designs for the application. And with this, I'd like to thank you, and I'm open to questions. Thank you very much.